Welcome to Pomodoro Joe for Saturday, February 18th, 2023. Today we're looking at LeetCode problem 226, invert binary tree. This is an easy problem. Given the root of a binary tree, invert the tree and return its root. Pretty straightforward. And they have an example here to show how the inversion works. You can see here's the original tree, and then on the right we have the inverted tree. And if you look, it's kind of a mirror image, a left-right mirror image of the original tree. So you can see we're essentially just swapping the left and right branches. Take a look at our constraints. All right, we have fewer than 100 nodes. Should be pretty straightforward. Okay, so I think I'll do this one a little bit differently. I will go through, write the code really quick, then we'll do some optimizations, and if all goes well, at the very end, I'll go back and sort of explain some of the theory behind it. With that, we'll put 25 minutes on a Pomodoro timer and get started. So anytime I approach a binary tree problem, my first thought is recursion. So here we go. We got our base case. So if we don't have a node, then we'll just return that non-node. Now, otherwise, I have to swap the left and the right. Now I know it's tempting to say something like this. So it's really tempting to say, oh, I'll just swap, just set the left to the right and the right to the left. We've swapped our branches, we're all done. Now this won't work. The problem here is we've assigned our right node to our left node, and that's essentially just clobbered our left node. Our left node is now the right node, and whatever was in this left node is gone. So then we assign our left node to our right node. Well, this has already been assigned to the right node. So now we're just assigning the right node to itself, and we've completely lost our left node. So you can't do this. But Python will let us put multiple statements on a single line, so we can do something like this. So in this case, we're assigning our right to the left and our left to the right. Problem solved. But we still don't have a recursive case. What we really want to do is assign the recursive call of the right to the left and the recursive call of the left to the right. So we'll do that now. And that should do it. Pretty straightforward. Let's see if we pass. And we're passing. Let's see how well we do. All right, and we pass, beating 94.82% of other algorithms for runtime and 94.86% for memory. I actually don't know if I can do better than that. So our first solution might be our only solution. So how does this work? I'll spend a little bit of time to walk through this. I don't think any more optimizations are needed. So we're using a recursive function to solve this problem. And with any recursive function, you'll need a base case. The base case is the case in which you're done doing work and you just return. You don't have any recursive call with the base case. So in this case, our base case is just if we don't have a root node, we'll just return the root. So that's our base case. Now what's our recursive case? Well, we have two recursive cases. We have one for the left branch and one for the right branch. So in this case, we're going to call invert the tree of the right node. So we're going to basically call this same function on the right node, and whatever we get back from that, we will assign to our left node. And we will also call a recursive call on the left node and assign that to our right node. And then at the very end of everything, we just return the root because the root, as you can see, does not change. So that's pretty much the entire algorithm. I think I'll leave it there. All right. So as you can see, this simple algorithm actually works pretty well. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can try this on your own. Try to do this without referring back to the video. Go check out this problem on LeetCode. Try to work it through on your own. See how well you do. If you get stuck, you can always come back to the video and check it out. It's a short one. All right, folks. Hope you had fun. Hope you learned something. Hope you enjoyed this. Hope you can go out and write better code.